onto manifolds. This is something that's quite an interesting application of microfluidics. Came from an existing customer who asked us if we could make a valve manifold. We'd never even thought of it before, but we were able to. They, as I say, with the other example, to machine and bond a manifold, you're often looking 6 weeks or so lead time. We were able to make these parts in a day or two, and that's opened up some huge opportunities for us within the fluid handling lab automation sector. We've been doing a lot of work with a variety of valve companies. The top picture there, you can see, is an optimized model where we've basically taken all the excess material out of the manifold. We were presented with a design which was to be originally 3 layers of acrylic to be machined, drilled, bonded together. And as I say, that would be 6 weeks or so. We were able to print that in 11 hours, I think it was, to print that. But then we took the whole design, optimized it. So we took out all the excess material, made the most of 3D printing, got rid of all the right angle corners for the fluid tracks to improve fluid flow, improve the manufacturability. And we got that print time down from 11 hours to 2.5 hours. And typically the quantities that manifolds like this are required in, it's a few hundred, it's a few thousand. So actually the batch production of 3D printing works really, really well here. So when we looked at the costing of that, we could 3D print the equivalent for pretty much the same price as a machined part, but massively quicker. We optimized it, we reduced the cost. So with the material we got down, we got 70% of the material out of it. We knocked 80% of the cost up to that. So over a quantity of 200 of those, it works out at a saving of £36,000 to 3D print them rather than machining, which blew me away when we worked that out.